Here in Taiwan, we might have this prejudice that this company is well supported by Philips, the Dutch government, even the European Union. Everything is in harmony. But actually, from your book, it was pretty much a roller coaster ride in the early days.
Well, I think the word harmony is not right. No, it's. I think horror show is better. Yeah. There was this first start of ASML with 40 engineers. They were kind of reluctant to leave Philips because Philips was quite comfortable. Right. Great secondary pay, so nobody wanted to leave. And they also got a machine that nobody actually wanted, so they had to improve the machine.
Hi, you're watching the Business Next podcast program. We're glad to have us today, the author of this book, Focus the ASML Way, the author Marc Hijink with us. Hi, Marc.
Hi, thank you, John. Well, actually, I think the Chinese title is Builders of Light.
That's right.
Yeah, love that title too.
I think they also pay respect to the previous documentary in Taiwan called the Mountain Builders.
Yeah, a beautiful documentary. So I've heard. I haven't seen it yet.
You haven't seen it?
No, but I'm eager to watch it.
It's basically about back in 1974, the government here has a plan to organize a team and send them to the United States to learn about the whole thing, about the semiconductor from design, manufacturing, testing, packaging, and equipment.
Well, the result we see this day.
In 76, they sent a team and they learned everything and came back to build a fab here. And then spin off a company named UMC first. And in 1987, TSMC, the second project.
Well, yeah, of course. Well,
so basically, your book title in Chinese, you related to the whole thing of the semiconductor industry development here in Taiwan.
Yeah, definitely, because there are a lot of resemblances. If you look at the start of ASML in '84, so 4 decades ago, and the start of TSMC, like these companies were pretty much aligned from an early start. And I must say, okay, ASML is of course a very important player worldwide. So, but TSMC has also been this partner that they were able to experiment with and tweak with, because there was also like a cultural match between our two countries, and the engineers usually get along pretty good.
Right, and these two companies actually have some connections. Went back, the old days, because TSMC's first invention included Philips.
Yeah, well, yeah.
That's the mother company of ASML, right?
Yeah, I found it fascinating to research, because when Morris Chang founded TSMC, he needed a technology partner. So he first started looking in Japan, and they said, no, we don't want a competitor as close by as Taiwan. And he went back to the US, to Intel and Texas Instruments, and they both said no. And so his last choice was, well, okay, for God's sake, Philips. And Philips jumped in because they had the technology, they had invested a lot in a European project that kind of failed.
Right.
But the technology was all right, but the timing was way off. And so they decided to take a share in TSMC, which was actually a very good choice. And it also opened a door for ASML to get in. And I think it was thanks to a Taiwanese company, Hermes Epitech, who was also a service provider for ASML back then, that they got the opportunity to deliver their first batch of lithography machines, 27 of them. And ASML was still in a very rough place back then, because they were just starting, on the brink of bankruptcy for a couple of times. But this first batch of 27 lithography tools to TSMC, they burned. There was a fire, and so the insurance company had to pay. ASML got the opportunity to deliver another 27 machines, and it kind of kept the company afloat, which was it was a very good start, thanks to the fire.
Yeah, you know the history very well, and you spend years researching, collecting data, and interviewing all the key figures in ASML.
Shall I share something of my background?
Yeah, sure.
So like you're an avid technology reporter with decades of experience.
3 decades, actually.
3 decades. Well, I guess I won't reach 3 decades, but I've been a technology reporter for about 20 years, I think. And last 15 years, I've been covering ASML in the Netherlands. So I work for a Dutch newspaper called NRC, and they gave me the opportunity to, well, focus on this niche in, and which is now a very big niche.
That's a luxury back then, right? Just to cover a company.
Yeah, definitely. Now, not only ASML, but I also covered big tech companies like Apple and Google and Microsoft. But as ASML grew bigger and more important, it made sense to, well, focus all my attention on this company. And during COVID, so back in 21, I got the opportunity to spend 1 year behind the scenes at the company, which was awesome because it was right during the chip shortage. It was right during the time when all the geopolitical tension really started to get serious. And it was also during the time that there was a lot of interest for ASML from the outside world. So I wrote a long read, like a long story in a newspaper. And then a publisher reached out to me and said, hey, do you want to write a book about ASML? I went back to them, I said, I got a book offer. I spent another 2 or 3 years behind the scenes again, so we can create this objective, transparent image of the company. And well, they had some doubts initially because for them it's kind of scary to let an objective reporter into their bond of trust, so to speak. But the end result is that they allowed me to write this objective, adventure, so to speak, about how they became this big global juggernaut. And they also allowed me to find other sources, not only the company itself. See, I don't own any shares in ASML, so there are stories in it that the company wasn't too happy with, but they were happy with the fact that it was an honest, picture I painted of the company.
Okay, so that's what motivated you to write the book in the first place, right?
Yeah, and I think it kind of aligned with the urge of ASML that they needed to be less obscure because there was so much attention for this company from the outside world, and it used to be that nobody cared what ASML was doing, especially in the Netherlands, because we don't have any fabs. But since it has become like geopolitical sensitive and also way too big for the Dutch to accommodate its entire growth, there's a lot of public attention. ASML's in the headlines constantly. So they also want to tell their own story. And they trusted me in telling that story. And I still have to pinch myself in the arm saying that a publicly listed story with over 40,000 employees allowed me to write it. And I must say, I think most of the effort was to explain their difficult technology in layman's terms. As you know, you're a technology writer or you're a reporter, so it's very hard to translate all these very complex technology, engineering stuff, physics, in a way that a layman or ordinary people, or in my case, my mother, can understand. So I put a lot of effort in it, and ASML provided me a lot of speed courses in their technology, how a lithography machine works, and they also helped me dumb it down for an average reader. And I think looking back, I'm particularly happy with the fact that that was successful. So it's an accessible book. It's not only for engineers, it's not only for people who are into the industry or into the politics, it's also like an adventure because there are some crazy people working there at ASML. Right. Well, you've read it, so you experienced it.
You know, it's interesting that maybe more people here in Taiwan care about ASML than in Netherlands.
Yeah.
Because I think most people learn about this company because it's an important partner to TSMC in the lithography machine aspect.
It was, John, it was fascinating for me to experience when I was here in Taiwan the first time researching for the book in 22. Then I arrived at customs. It was the end of the pandemic, so I had to quarantine for a couple of days. And I said, what's your purpose of visiting the country? So I'm writing a book about ASML. Oh, you mean ASML lithography, whatever.
The EUV machine,
yeah,
something
the
EUV
like that. What? And if you were to say, okay, ASML in the Netherlands, everybody would scratch behind the ears and say, huh, what? Well, something IT related, chip related. But there's a reasonable explanation for that, because ASML has been doubling in employee count every 5 years approximately. So it used to be pretty small and it used to be less important. But since the industry has grown so rapidly, ASML as a monopolist has grown accordingly. And in The Hague, so where the government of the Netherlands resides, there was not a lot of attention, because they're usually politicians in Europe, at least, they think technology is quite complicated. And if it's complicated, you better stay away from it. So it wasn't until 2018 when the US tapped the Dutch Prime Minister on the shoulder and said, hey, this EUV machine, they're selling it to China. Do you know what kind of company you have in your own backyard? Then they started realizing, oh, okay, now we have to act accordingly.
Okay. That's Joe Biden, right? The President Joe Biden.
I think it was the first Trump administration, actually.
Okay.
Yeah.
Okay. And people here in Taiwan learn about EUV and also ASML because it builds one of the most expensive machine so far, because the high-end EUV would cost like $370 million per unit, right?
Even more.
Even more.
Yeah, I think it's about 400 million.
400 million.
Inflation, John. Sorry.
I see. Okay. It's equal to the F-35 jet fighter, which both cost a lot and require a lot of technology and especially to build.
Yeah. Well, I think that's an excellent comparison, because there are a lot of similarities between the way ASML is like built as a company, structured, and the aviation industry.
Right, like a Boeing or...
Yeah, because usually these aviation companies, they're like the architects. So one part does the design over, and he has the responsibility of the entire design of the plane. Yet the engine is usually bought at another company. There's another supplier for the wings or the chairs, you name it.
The big is sourcing everything from outside, right? They just design, assemble that.
Yeah, and you could compare ASML's structuring as the same way. And it kind of set it apart from its competitors. So if you look at the value, an average value of a lithography tool, 80% of the value is provided by suppliers. And which is a lot if you compare that to competitors like Nikon and Canon. Because back in the early days, these were conglomerates that tended to use their own ingredients, so to speak. And ASML, it started out with nothing. It was kicked out of Philips back in the 80s. And okay, now we have to build a machine. Okay, let's first start with an optics partner. So they reached out to Zeiss and they built machines together with some old Philips parts, but also VDL, a Dutch player, and you name them. I think by now it's like 800 suppliers, mainly from Europe. What it results in is a pretty agile organization. So during downturns in the chip industry, ASML kept its R&D spend on the right level, while a lot of their competitors, Nikon, Canon, had to slim down and cut their budgets. But if you keep your R&D at the same level, you're able to create a more innovative machine when the upturn begins. So that was ASML's game. It took them a while to find out because they had a very rough start. But once they got there and they got the market share over 50 to 75%, it got easier, because when you get all the capex in the industry, or practically all the capex in the industry, you have more money to invest in new technology, and you can out-innovate your competitors. That's the reason. That's the way of thinking.
Yeah, we'll get to that competition part, like the Japanese Canon or American Silicon Valley Group later.
Yeah.
Let's talk about ASML in the early days, because it was founded in 1984, a spin-off from Philips. And back then it was some hard time for Philips and for ASML as well. But here in Taiwan, we might have this prejudice that this company is well supported by Philips, the Dutch government, even the European Union. Everything is in harmony. So, but actually, from your book, it was pretty much a roller coaster ride in the early days. So how was that?
Well, I think the word harmony is not right. It wasn't.
It's
I
like
think horror show
tsunami
is
or
better.
hurricane.
So if you look back at the reason why Philips had to spin off ASML. So Philips in itself was a conglomerate. It built TV sets, razors, you name it.
Light bulbs.
Yeah, light bulbs. And it also built its own ingredients like chips. And it even built its own tools, like the lithography tool. It was supposed to build chips for its own devices.
Not only conglomerate, but also IDM, which we call like, back basically in the 80s, 70s, it's a center by fab. And then everything design, fabrication and testing and packaging all together in one company.
Well, and looking back, it seems like an old-fashioned way of running a business. But the positive side effect is that Philips also had an R&D lab called NatLab, which did a lot of fundamental research. And one of the research projects was a lithography machine. Well, lithography is hard, and they were inspired by for example, the US technologies, and but they figured out a system was better in alignment, faster in alignment, so you had a higher throughput. So they created this kind of prototype, which was not very usual because it was running on hydraulics, on oil. Well, the last thing you need in a fab is oil, of course, because it's polluting. But the technology in itself had potential. But Philips was not able to sell the machine because they were like competitors to their potential customers. So they were very afraid to buy anything from Philips because, well, they probably use the best technology first for themselves and then sell afterwards. So for this lithography tool to have a chance, because it had potential, as the other founder, Arthur del Prado, saw. He was the founder of ASML International, also a Dutch company. So,
but he was seldom remembered from the company history.
Yeah, and I tried to correct it in this book, that he was like instrumental for the first start. He was the one to ignite and to start up companies. He really had a good sense of what had potential. He was not always the best at, well, he had poor timing, to be honest. But in this case, he really made the right point. So this technology has potential. And with help from the EU government and also The Hague, so the Dutch government, there was this first start of ASML with 40 engineers. And they were kind of reluctant to leave Philips because Philips was quite comfortable. Great secondary pay, so nobody wanted to leave. And they also got a machine that nobody actually wanted, so they had to improve the machine. But in the early days, their first employee, Martin van der Brink, who turned out to be CTO and co-president, well, for the next couple of decades, he was a really driving, charismatic and person. And the first director I spoke to,
a very passionate, but also very bad-tempered guy.
He could be awful, and people often left his meetings like crying because he could really explode. But that was also his enthusiasm, and it's also like this Dutch way of doing business. So you have to be very honest and direct.
It's a bit like Morris Chang in TSMC in the early days, because a lot of people were afraid at that time to have meeting with him because it always got criticized very badly from Morris.
Yeah, and the funny thing, I reckon, I first comment on the directness, and then I comment on what our countries have in common. So the directness of Martin has a goal. It's not only about him making his point, telling other people what to do. He's also expecting like this a reaction. He's trying to trigger a reaction. He wants to be challenged as well. So I remember the first time I stepped in his office. I had already done a couple of interviews, but then it was sure I was going to write a book. So I stepped in his office. He said, "Okay, so why the hell are you going to write a book about ASML?" So and he was trying to wipe me off my feet, and I was kind of scared. So I just wanted, Okay, and after 10 minutes, once you get his attention, once you get his dedication, he has great stories to share. But this initial, well, he says it jokingly, but he can be pretty convincing, I must say. He scared the hell out of me. And but once you got there and you got to this level of trust, and he wants to share his stories, they're awesome stories about how he actually built this machine, because this guy was like the Steve Jobs of photolithography. And now coming back to Morris Chang, I think one of the reasons that TSMC and ASML got along, or their engineers or their management teams, is the reason that they're both from small countries. There are countries that are used to doing trade with other countries as well. So you have to be able to communicate and be direct, because if you're being too polite, well, you lose time.
Right.
And you can discuss things, but in the end, it's just adding latency. And the last thing you need in this industry is latency, of course.
Right, right. You need someone like that to, like Steve Jobs, especially in the early stage, to move things forward.
Yeah.
If you're a nice guy, I mean, everything will move very slow and lose the opportunity. Of course.
Yeah, I agree. So I think Martin was the designated driver for ASML, and he was also the kind of guy that really could pin out the roadmap, because the whole industry trusted him in building this roadmap, because he had to get his customers along as well. So Martin, but the whole ASML management, Peter Wenning as well.
Right.
They spent a lot of time at their customers, knowing what the need for new chips, new designs was, so they could build the right machines. Because you don't want to buy these build these expensive machines if nobody wants to buy them. So Martin kept things aligned, quite literally.
Yeah. So Blink and Wenning, they're like a team, right? The good cop, bad cop. You need that kind of combination, like Steve Jobs needed Steve Wozniak in the early days.
Yeah, I saw you once did an interview with Steve Wozniak. Eh?
Yeah.
I would describe Peter and Martin as yin and yang. So they were like complementing each other. Right. But they were both very different characters, because Martin was so explosive and he also hated status. So he was, ASML, especially during its early days, was as flat as the Netherlands. So no hierarchy. So everybody could shout at everybody, and okay, there's somebody trying to get everybody in line. But as it grew bigger, of course, there's a lot of non-engineers added to the company as well, organizational stuff. And you become more important to the outside world. So Peter Wenning was also, he called himself half a psychologist to, well, to keep the engineers from fighting, or to mend broken hearts or whatever. And Martin was also, okay, we have to get there, we have to get there. But to the outside world, Martin was not, well, the most diplomatic person you could meet. So Peter Wenning was often the one doing negotiations with governments or with other people in the surrounding of ASML headquarters. So there was a brilliant fit. And it's quite unique that the company has like two presidents leading, and the way that they succeeded was that they knew they were quite different, but they started looking for the common things that binded them. And that was a good starting point for them. And they respected each other's differences.
Right. And in your book, also you describe some stories about the early days, how tough they went through. And I think one of the key factor for them is to penetrate the U.S. market, right? How they win the Intel's contract and later on acquire.
I think you mean AMD.
Yeah, AMD.
Oh,
okay.
Yeah.
Okay. So how did that go?
Well, AMD was a very early customer for ASML, and I would love to show you a picture of the first headquarters of ASML, because it really looked like a Silicon Valley building. They had their architect build something that could have been in Silicon Valley, because they wanted to attract these customers. Well, it's very hard to get the incumbent, the market leader, to switch lithography tools, because it's like the main tool in the fab. You don't want to alter that. You're not gonna risk it. but the competitors are willing to take that risk anyway. So back in the day, the US was still leading in semicon manufacturing. And one of the challenges for Intel was, of course, AMD. So AMD was willing to experiment, and they were not happy with the Japanese lithography makers. So ASML just published an ad, actually, in a magazine in the US, say, "Jerry, we hear you," and it was a referral to the CEO of
Jerry Sanders.
Of AMD back in the day, and said, "Okay, we can build this tool for you." So they were asked to deliver a tool for a beauty contest. So it's like a game between several suppliers, and it was in a time when the industry still had like 10 different lithography makers. ASML also provided one of its first tools, and was the first tool actually with electric engines. So no oil, no hydraulics anymore. But they hadn't really experimented with it because they were always in a hurry, especially for beauty contests like this. So when they first switch on the machine, they realized that the engines were completely skew, and the yield would be awful, and the alignment would be awful. So they they only had 36 hours to prove that their machine was best. So they made a quick phone call to Veldhoven. And some guy grabbed a couple of new engines in a suitcase, hopped on a plane back to the US, and at night they snuck into the factory using, I think it was like a key card they had borrowed, and didn't tell AMD anything. And the next day, just the machine was running as it should, and they got the contract. And it kind of is an explanation for or an example for the cowboy spirit that was at ASML, because they had nothing to lose. They were kicked out of Philips, on the verge of bankruptcy, and actually they didn't know what their customers needed. So they had to learn, and they were eager to learn, but they did have, well, if you're a big company, you have lots to lose, and you're more careful. But this cowboy spirit, you can still see it in the way ASML is acting now.
Yeah, for your information, I interviewed Jerry Sanders in 1997 when he came to join the TSMC's 10th anniversary.
Okay.
He has this famous quote that real men own fabs.
Yeah.
So he didn't basically give contract to TSMC for the foundry business. But later on, when it's Lisa Su, it's female, it's okay. Basically.
And then that makes sense. Well, real men have fabs. It's like an old-fashioned statement. Yet you see that even though fabless is considered like the best investment, if you look at stock price, I think politicians really want fabs because they want to own the supply chain, or make sure that there won't be chip shortage again.
That's about the geopolitical part, which we'll come to later.
Yeah.
So, and also ASML basically survived and beat the competition from their Japanese counterpart like Nikon and Canon.
Yeah.
So how did that part go? Because back then, these two...
so what do you want to know?
Because these two...
What are you referring to? Because I think there were like two major points in history where there was a big clash between Nikon and ASML. The first one was in, I think it was 2001, when Nikon started this patent war against ASML. And they were scared shitless because they didn't expect anything to happen like that. Because ASML was so much focused on the invention of new machines, new technology, to keep its organization running. So it was very hard to stay afloat, and they were already listed. And now suddenly this old competitor, and old means you have a stack of patents, which means you can easily win a patent war, threatens to close down the company, or to close down access to markets. And the reason for that was when ASML was like kicked out of Philips, they didn't get a lot of patents. Philips used to patent things like CD players, and ASML was considered, well, lithography was not considered too important. So ASML spent a lot of time making sure that their new patents were listed and also approved. But they were scared, and next time, but they got a recent deal out of the first patent war. So usually you sign a contract, okay, we will not do claims for 5 or 10 years. And ASML knew that there was going to be a next case in the future. So, but this time they became prepared. They were prepared. And you know how they prepared themselves for the next patent battle?
No.
Well, this is in the chapter I call the camera that did not exist. Which is, you know, Nikon is of course world famous for its excellent digital cameras. Right. They make a lot of money with that, especially during the 2000s. What ASML did secretly, it built a shell company and it started buying up digital camera patents without anybody knowing. So it was very secretive. And their thinking behind it was that the once Nikon would file a patent claim against them again, because they tried to negotiate with Nikon during this period of time, but Nikon always said, no, we don't want to negotiate. So they had to prepare for another battle. And they built up this wallet of patents for digital cameras. And when Nikon started doing the patent claims again, they issued their patent claim for digital cameras. And Nikon was really upset because digital cameras is a huge market for them. And ASML was threatening the Nikon US market, which is huge. So that was really hurtful to the company. But for ASML and Zeiss, because they have shared IP, to be approved in this patent war by the US judge, they also had to prove that there actually was a camera on the US market that would be hurt by this Nikon patent infringement. And so they actually built a couple of prototypes of a camera. I think it's called the ZX1. And it's a Zeiss camera. You could never, couldn't buy it anywhere, but it was just built as a proof in this patent war. Okay, see, this is our digital camera. Nikon is hurting us. And then the judge said, okay, guys, figure this out. And for Nikon, this was one of the reasons for them to make a way better deal for ASML for the next couple of years. And the funny thing is, when I interviewed Martin van den Brink, he was walking to his cabinet, and there was a box on top of that saying ZX1, and it was a camera that never existed. And he said it was a lousy camera. It costed like 6,000 euros, I think. But nobody got any look at it.
Yeah. So that's a camera that does not exist.
It did not exist, but it was very crucial for the existence of ASML.
But eventually, that's a big win for ASML because they settled for less money than expected with Nikon.
For less money, and of course, they were kind of after 2 patent wars, they definitely realized, well, we have to be on our game when it comes to these patents. So now you see ASML is like over 16,000, 70,000 patents, and a lot of what I call informal knowledge. There's a lot of knowledge and experience within the workers themselves, of course.
Right. And after competition, let's talk about partnership, because like we discussed earlier, that ASML rely heavily on its partners, basically sourcing everything outside of the company, like work with Zeiss for the lens and also work with IMAX for the next generation spec, right? So how does it work to communicate and collaborate with these partners, especially Zeiss? From your book, the Germans are very tough when it comes to, you know, working together. So, but somehow ASML managed to go through all these challenges, you know, step by step, and you know, all the way to what today has achieved.
Yeah, let's focus on Zeiss, because the optic system is like the crucial part of a lithography tool. Well, I don't have to explain you what a lithography tool is. It's a copier, so you need a light source, and you need lenses and a mask and stuff that moves. So optics are crucial, and only Zeiss has the knowledge, at least in Europe, to cooperate on the level that ASML needed. And but for these companies to align, these two cultures had to find each other. And the Dutch culture, as I mentioned, is very flat, and there's no hierarchy, hardly any hierarchy. German culture is completely opposite. So there's a lot
of
hierarchy. Yeah, and also age matters a lot. And if you look at ASML, even if you're an intern for 2 weeks, you're expected to add to the conversation. So two completely cultures. There's another thing that was hard to align, which was timing. Because ASML, even though it's a complex machine, the assembly is pretty quick. So it's between 3 and month, and then you ship the tool to the customer and you build it up again. So it's a matter of months that you can ramp up. But for ramping up lenses, it takes years, because the crystals for the glass has to be grown, and these lenses, later on mirrors for EUV systems, have to be polished. Well, in the early days, it was done by hand, by craftsmanship. And of course they robotized it, but it's still a very long-during process. And the Zeiss expression was always, it's like a pregnancy. Even if one woman is pregnant, it's going to take 9 months, even if you put another woman next to her.
Also 9 months.
Yeah, so that's the wisdom of Zeiss. And for these companies to align, you saw that especially the commercial alignment was difficult, because it was hard for ASML to project what the exact outcome would be of the demand of the future. And Zeiss wanted certainty that they wanted to sell so many lenses or so many optical systems. And well, you know, things can change very rapidly in the semiconductor industry. So ASML had this agile way of thinking, and Zeiss had a hard time of adjusting to that. So it took a lot of swearing and a lot of negotiations to get those companies together. But as the importance grew, because it was the revenue was growing, so there were also the willingness to come to a deal and to an agreement grew. So they both knew how incredibly valuable their cooperation was. So they developed this slogan called 2 companies, 1 business. And this is still, these 4 words, sorry, are still keeping these 2 companies together. Because it's a very special relationship. It's like single sourcing. It's like a marriage.
Right.
And ASML is has a couple of these single-sourced relationship, and it takes huge amount of trust. And if you zoom out and you look at the semiconductor industry as a whole, you see that ASML itself is also like a single source for Samsung or TSMC or Intel. So these are very brittle chains.
Right. So does it have to do with the Dutch culture? Because, you know, in the 16th century, 17th century, the Dutch businessmen doing business all around the world. So leveraging the resources, whatever you need, and try to come up with the opportunity, you know, regardless of the difficulties. I think that's pretty much the Dutch.
I love that comparison, but
culture.
So I think that definitely helps. There's another element to it, because, you know, the book is also about what it took to get EUV running in an economically viable way, because EUV was an invention. It was researched in the labs of Japan, in Europe, in the US. US were very important when Intel helped build the first prototypes, but it wasn't getting commercialized because it was too difficult. And you need a kind of a long-term view and a long-term vision that you find in Europe, especially a couple of countries, Switzerland, Austria, Germany, France, Belgium, Netherlands, they are all connected by the Rhine River. So the Rhinish model, so to speak, consists of many engineers that are used to cooperating and to doing fine craftsmanship. If you look back in the history, centuries ago, there's the Swiss watches are world famous, of course. So this accuracy and now even on the nanometer level is there in their DNA. But it takes a long-term vision to build it. And if you look at the Anglo-Saxon way of doing business, which is about optimizing profit, usually on the short term because you want to keep your shareholders happy. ASML has always been about the other side, about the Rhenish model, because they realize, okay, our goal is the effort in the distant future. It's not about optimizing profit. The profit is like a buy effect almost.
It's interesting that you bring this to the Rhinish model and also the Anglo-Saxon model. Because they need to balance the two, right? In the semiconductor industry, people move very quickly and technology changes very fast. So
yeah, well, I heard this great comparison that the industry is like a shark. It has to keep on moving and moving, otherwise it dies, which I totally agree. But there's another element that's not moving at all, which is the relationships between all the people in the industry. They usually go back like decades. Morris Chang has been as in this industry for ages. And if you look at the people at ASML, it's not a lot of usually guys that know each other. So the network is pretty small. And even though there's a lot of movement and a lot of growth, but the people holding it together, that's actually a pretty small bunch. And this bond of trust is very valuable. And that's also why it's so painful that it's now been, ruptured by all these political forces, because they're not used to it. But it's my theory that the industry has become too crucial, too important for the rest of the world to just only rely on efficiency, on economical logic, on concentration, because this, chips are way too valuable for society, for the rest of the world. And the pandemic has taught us that we're so depending on these crucial building blocks of society.
And looking ahead, are there some potential or existing risk for ASML? For example, like when we move to this advanced process technology, TSMC has become almost the sole customer for ASML, in addition to Intel and Samsung, which the other two are smaller compared to TSMC, and also the geopolitical tension.
Okay, let's first go. I think TSMC used to be ASML's biggest customer for a long time, but if you look at their the regional division of their last year's revenue, I think China was the biggest. So there's a bunch of players there, and we've also seen an increase in ASML's numbers in the US and Japan. So, but if you look at what the that's a region, but usually these are TSMC regions as well. The TSMC's expansion is going on in Japan, in Singapore, in the US, also in Europe. So there's a dependence on one player. On the other end, Samsung is picking up its pace as well. It had a great deal with Tesla, for example. So the expansion plans in the US are growing. I think Samsung is kind of awake now. Now they've seen a lot of competitive, a huge growth at SK Hynix. And so I think the ecosystem is pretty healthy, but Intel is in a bad place. And for ASML, they usually think of this market as an end market. So as long as there's an appetite for chips in the world, which usually depends on global economy, there's an appetite for chip machines. And no matter who manufactures these chips, they're going to need ASML's machines because they're practically monopolists. But I do agree with you that if just a couple of players are left, then there's less need to innovate. But we're going to see that anyway, John, because now there's less efficiency in the industry because we have to duplicate or replicate parts of the of the fabs, which makes it less efficient, which leaves less money to invest in new technology.
For sure. And with TSMC now building new fabs in Dresden, Germany, how would that help to boost the collaboration, the partnership among ASML and Zeiss, perhaps, or the ecosystem of semiconductor in Europe?
So if you look at any semiconductor hub worldwide, then you see these huge fabs, and around them is a circle of suppliers. ASML is there, KLA is there, Applied, you name them. And these suppliers and these ecosystems attract other players as well. So one of the reasons that TSMC even considered Dresden in Germany is the reason that there was already like a supply chain. There was Global Foundries and Infineon, which both have fabs there, and also Robert Bosch. And they have a supply chain of consumables, for example, or chemical deliveries, and also ASML and other companies are there. So for TSMC, it was very easy to pick that location for ESMC with the appropriate amount of subsidies, of course. So it took them a while. And I would expect that semiconductor hub to grow. It was supposed to have Intel as well, because there were plans to build a huge fab in Magdeburg, but it was put on ice, and I think it's now completely off the table.
Because it needs subsidy from the EU or German government, right?
Yeah, it was a subsidy from German government, and I still think there's an appetite for highly advanced chips in Europe, because Europe wants to build its own AI stack as well. For which you need the semiconductor manufacturing, of course.
So that leads to my next question, that recently, this week, ASML made an investment in Mistral, the AI language model in France. So what's the reason behind that, in your opinion?
Well, their timing is perfect, or your timing is perfect, I must say. The reason behind it, for my book, I got the opportunity to visit all of the major ASML divisions, and also one division in San Jose in Silicon Valley. There's this combination of actually a Taiwanese company that ASML bought back in 2016 called HMI, and also a US/Chinese company called Brian, which they bought in 2006. And these do computational lithography and OPC, but also metrology and inspection. And that's kind of the knowledge about how wafers are actually being produced. So whenever a wafer gets out of the lithography machine, it has to be checked, and it creates huge amounts of data. And while every chip gets more and more transistors, over 200 billion now, latest NVIDIA chip, you need to do a lot of metrology and inspection to make sure there are no errors on the disk. So to digest and analyze this data, ASML has already been switching from CPUs to GPUs, which makes sense because these parallel processes work way faster. So they have cooperated with NVIDIA already, and if you look at the results, they're promising. And that's the reason why they want to have their own models, because, you know, you're dealing with really sensitive information. It's very valuable, and that's the reason why TSMC is so secretive about these processes, because, the value of the company and the trust of the company is depending on it. So you want to make sure, as supplier to TSMC or to Samsung or whatever, that you're able to build secure building blocks. And AI is going to be one of these building blocks, digesting all the data, drawing conclusions. And the funny thing, the Martin van der Brink, you know, the real genius behind this holistic way of thinking.
The backup basically, who we mentioned earlier,
He often called AI voodoo software, because it's very hard to get an insight in how actually the computation is done. It's just throwing a mass amount of data and finding patterns in it. And he had this idea that he still thinks the human mind is better at perceiving physical models and solving mathematical problems, because then you add value. If you just trust AI, then anybody can do the job. So you have to add value. That's Martin's opinion. But of course, you need voodoo software, so to speak, to speed up processes and also help ASML develop their own software a bit faster. So it's actually a way to be more efficient.
Since you mentioned voodoo, just need to clarify, because you also give an example of this voodoo in one of the Arizona fab when they use ASML machine. But everything's okay, but it just doesn't work. So that's somehow hire a priest to look at everything and suggest to put a little red tent over there.
It's a
crazy. And everything went well after that.
It was a crazy.
So it's a different voodoo.
Yeah, it was a crazy story. And once I heard it, it took me, I think, 2 or 3 months to find 2 other sources to acknowledge the story, because I couldn't trust one person, of course. And well, the gist of it, that there was a fab of a company who shall not be named.
Okay.
There was
you didn't name them in the book.
No, because I thought the story is funny enough, and it was built on an old Indian cemetery, and they had no explanation for a certain tool that wasn't working properly. So whatever they did didn't work. And then somebody thought, oh, maybe it could be a spiritual thing. Let's call in a shaman, a medicine man.
Shaman.
So they called in the shaman, and he saw these building cement blocks at the entry. He said, "Oh, they look too much as tombstones. Get them, just get rid of them." Then he was dressed in a bunny suit, so in a clean room suit, and he walked in and said, the spirits are not happy here. They need something red. Give them something red.
Right.
And they saw this old box that used to have a Zeiss lens in it, and just folded it into a tent and put it on top of the lithography machine.
Right.
And from that day on, it worked perfectly.
Right. You know what? We have this kind of spiritual phenomena here in Taiwan too.
No.
In every fab, almost every machine, beside would be a guai guai. It's a child's name.
Yeah.
So I'm not sure you have the opportunity to go to. You will see that they put guai guai in
excellent point, John. I should
machine.
have noticed it myself, because in a lot of factories you see a small altar and to please the spirits.
Yeah. So we need technology, but also we need something beyond technology.
I think what my book shows is what the human touch is in the technology we do use today.
Yeah. So final question before I let you go, and also you asked that question too in your book, that because there is a ban on export of this high-end machine, this lithography machine, to China. So China tried to build up their own. So do they have any opportunity whatsoever to replicate ASML?
I think the shortest answer is the laws of physics are the same in Beijing as in Brabant, as I write it in the book. So of course, it could be replicated, but it's very hard to keep it to get it running and to keep it running. So it took ASML 15 years and 15 billion euros and a lot of brilliant minds and a lot of mistakes, and also a culture that's used to cooperate. And I think that's a huge moat around ASML's way of thinking. It is very hard to replicate, especially in other countries, because it's also an engineering culture you mainly find in Europe, especially in the Netherlands. So that's a cultural thing. Looking back at technology, of course, everybody's attempting to build new light sources as a replacement for EUV. And on the other hand, it's the light source is just one ingredient. You also need the optics system and the fast stages, and you need to keep everything together. And that takes a lot of learning cycles. So it's going to take a lot of time.
So we reverse engineering worked?
I think they have a hard time reverse engineering. Otherwise, we would definitely have seen it already. They're trying. I know SMEE has tried. I know Saikari is also trying to reverse engineer. But once you have these building blocks, you still have nothing, because the machine is completely useless if you can't get it running and keep it running.
Okay. So thank you, Marc. We have talked a lot about the book and also something just beyond the book, but I think it's only 10%, right? So I strongly recommend our audience to read this book. There are another 90% interesting stuff in this book waiting to be explored. So great to talking to you.
Thanks, Sean.
Marc,
okay,
look forward to seeing you.